Alright, in another fun and exciting video on physics, what we're going to be talking about is a different type of energy. You see, in the last video we talked about kinetic energy, KE. KE equals half mv squared. Not in today's video though. In today's video we're going to be talking about a special form of energy. So today we're going to be talking about gravitational potential energy, GPE. Gravitational potential energy. So this is energy due to the fact that you are suspended from a certain height, h. So this is energy stored by an object due to it being suspended from a certain height, or at a certain height, that's what I should say, at a certain height h. Okay, so at a certain height h, an object will carry some form of stored energy. And the reason why it carries this form of stored energy is because if it were to drop from that height, the object would gain kinetic energy. It will speed up. Okay, now one thing that's worthy to note here is that energy cannot be created or destroyed. It is merely transferred from one form to another. So if I have an object gaining speed due to it falling at a certain rate, 9.8 in this case due to gravity, so if an object is speeding up and gaining kinetic energy, it must be gaining it from some other source, and in this case it's this height, it's this gravitational potential energy. So how do you calculate gravitational potential energy? Well, the gravitational potential energy depends on the mass of the object. So the bigger the mass, the more energy that it stores. That makes sense. I mean, a falling truck versus a falling feather would have different energy storages because there's more stuff inside the truck than a feather. It depends on the gravitational acceleration rate. Okay, so if you're further away from the center of the Earth, g would be lower, and so the gravitational potential energy stored would be less as well. But what if you're at a different height? Okay, if you're at a different height above the Earth's surface, then if you have further to fall, I want you to think about this. If you have further to fall, then you probably have more energy stored because the object that falls will gain more and more speed the more and more it falls, right? So let me say that again. If an object is at a higher height, okay, the object has more distance to fall. If it has more distance to fall, it has more speed to gain from that fall. This means that its energy stored in the fall will be more, okay, due to its increasing height. So that's important to note here. So this is our formula. It is mgh, gravitational potential energy. All right, now let's use this in a question. Okay, so Mr. Nikola, this is an example. Mr. Nikola falls from a height of 100 meters. Okay, so he's in trouble, right? He's in trouble. He falls from a height of 100 meters. His mass is, how massive am I? Well, I just had a Big Mac. Okay, let's say 65 kilograms. Okay, 65 kilograms. That's my mass in SI units. And I want you to remember that we got standard units, right? So the standard units for distance are in meters, Standard units for mass, kilograms. What is his gravitational potential energy, GPE? Well, all you have to do is calculate the GPE, and that's mass, okay, times the gravitational acceleration times the height of 100 meters. Now this is how much speed you pick up per second of falling. Okay, so this is speed increase per second as you fall. So you increase 9.8 meters per second. Okay, so every second your speed grows by 9.8 meters per second. Let's round that to about 10, just because 9.8 is pretty close to 10, and I want to do this in my head. 65 kilograms, okay, 65 times, let's do the approximate sign, 65 times 10 meters per second squared times 100 meters would be the same as 65 times 1,000, basically, because these group together to make 1,000, right? So basically, I'm approximately at 65,000 kilograms meters squared per second squared. Notice how the meters times a meter gives me a meter squared, right? Now, this unit in the last video we figured out was the joule unit. What's more important is that we've got 65,000 joules. 65,000 joules can be rewritten as 65 kilojoules of energy. So me falling from that height, okay, with my mass, due to gravity, can generate as much as 65,000 joules, or 65 kilojoules. Okay, so this is how I would calculate my energy stored due to my falling from a height. Okay, what we're going to do in the next video is we're going to talk about energy conservation. So in the next video, and I'm super excited about this, next video is energy conservation. Now what that means is if you have a system and you assume that there is no friction in the system, then an object can freely transfer between kinetic energy due to speed and gravitational potential energy, and the total energy of the system is conserved. Okay, so it means the total energy of the system doesn't change. Okay, it's the same value. Okay, and that just basically borrows from the fact that energy cannot be created nor destroyed in a closed system. Okay, meaning in a system that doesn't get interfered by anything else. Okay, so in that system you will have energy conservation. The energy doesn't change. So I'm really stoked to talk about that. It's going to be a fun video. Thank you for watching. If you like this video, leave a like, subscribe, comment, and I'll see you in the next one. I love you. Peace out. Bye-bye.